Have you ever wondered how things grow really fast, or how we measure things that change on a massive scale like earthquakes or sound? That's where exponential and logarithmic functions come in. These powerful mathematical tools help us understand and describe some of the most fascinating phenomena in the world around us. Exponential functions are like rockets taking off. They involve a base raised to a variable power, which causes the output to skyrocket as the input increases. Think of it like this: 2 multiplied by itself 3 times, 2 times 2 times 2, can be written as 2 to the power of 3. The general form of an exponential function is y equals a to the power of x, where a is the base and x is the exponent. This simple formula can model all sorts of amazing things, from the spread of a virus to the growth of your savings account. For example, imagine you invest $1,000 in an account that earns 10% interest per year. After 1 year, you'll have $1,100. But here's where it gets interesting. In the second year, you earn interest on the original $1,000. The $100 in interest you already earned. This snowball effect is what makes exponential growth so powerful. Logarithmic functions, on the other hand, are like detectives solving mysteries. They help us figure out the exponent needed to reach a certain value, given a specific base. In simpler terms, logarithms answer the question, what exponent do I need to raise the base to in order to get this result? The general form of a logarithmic function is y equals log, base a, x, which can also be written as a to the power of y equals x. Notice how the exponent y in the exponential form becomes the output in the logarithmic form. That's because logarithms are the inverse of exponential functions. They undo each other, just like addition undoes subtraction. Let's say we want to find the logarithm base 2 of 8. In other words, we're trying to solve the equation 2 to the power of y equals 8. We know that 2 times 2 times 2 equals 8, which means 2 raised to the power of 3 equals 8. So the logarithm base 2 of 8 is 3. While exponential and logarithmic functions might seem like polar opposites, they're actually two sides of the same coin. They share a special relationship. They're inverses of each other. This means that if we apply one function and then the other, we end up back where we started. Think of it like riding a roller coaster up a steep hill, exponential growth, and then slowly coming back down, logarithmic decay. The two movements are connected, with one reversing the effects of the other. Another way to visualize their relationship is to imagine the line y equals x. If we plot an exponential function and its corresponding logarithmic function on the same graph, they'll be symmetrical across this line. This beautiful symmetry highlights the inherent balance between these two powerful mathematical concepts. Section 5. Exponential explosions, real-world applications in finance and beyond. Exponential functions are everywhere in the real world. They help us model things that grow rapidly, like populations, investments, and even the spread of diseases. Understanding exponential growth is crucial for making informed decisions about everything from personal finances to public health. In finance, exponential functions are used to calculate compound interest, which is the interest earned on both the principal and any previously earned interest. This powerful concept can help your savings grow exponentially over time, especially if you start investing early. Exponential functions also play a vital role in modeling the spread of infectious diseases. By understanding how quickly a virus can spread, scientists and public health officials can develop effective strategies to contain outbreaks and protect communities. Section 6. Logarithmic logic. Unraveling the mysteries of earthquakes and sound. Logarithmic functions might seem less intuitive than their exponential counterparts, but they're equally important for understanding the world around us. They help us measure things on a logarithmic scale, which is useful for dealing with vast ranges of values. For example, the Richter scale, which measures the magnitude of earthquakes, is logarithmic. This means that each whole number increase on the scale represents a 10-fold increase in the amplitude of the seismic waves. A magnitude 7 earthquake is 10 times more powerful than a magnitude 6 earthquake, and 100 times more powerful than a magnitude 5 earthquake. Logarithmic scales are also used to measure sound intensity, decibels, light intensity, and even the pH of solutions. By compressing a wide range of values into a more manageable scale, logarithms make it easier to work with and understand these important quantities. Section 7. Computing conundrums. How exponents and logarithms shape the digital world. Exponential and logarithmic functions are essential tools in computer science and engineering. They're used in everything from algorithms to data compression to computer graphics. Understanding these functions is crucial for anyone who wants to work in the ever-evolving field of technology. For example, in computer science, logarithmic functions are used in algorithms for searching and sorting data. Logarithmic time complexity is considered very efficient, as the time it takes to complete a task increases slowly, even as the input size grows significantly. Exponential functions, on the other hand, are used in cryptography to secure sensitive data. Public key cryptography, which is widely used to protect online transactions, relies on the difficulty of factoring large numbers, a problem that involves exponential functions. Section 8. The power of understanding. Why these functions matter. Learning about exponential and logarithmic functions might seem like a purely academic exercise, but these powerful mathematical tools have real-world applications that affect our lives in countless ways. From understanding the growth of investments to predicting the spread of diseases, from measuring the magnitude of earthquakes to developing efficient algorithms, exponential and logarithmic functions help us make sense of a complex and ever-changing world. By embracing the elegance and power of these functions, we unlock a deeper understanding of the world around us and equip ourselves with the tools to solve some of the most pressing challenges facing humanity. Section 9. Conclusion. Embracing the elegance of exponential and logarithmic functions. Exponential and logarithmic functions are essential tools for understanding the world around us. They help us model growth and decay, measure vast ranges of values, and solve complex problems in fields ranging from finance to computer science. By embracing the magic of these functions, we open up a world of possibilities and empower ourselves to make informed decisions about our lives and the world we live in. So, the next time you encounter an exponential or logarithmic function, don't shy away. Embrace the challenge and discover the beauty and power that these mathematical concepts hold.